So now I'm going to talk about calculating the arithmetic mean for samples and populations. Usually you won't see it called the arithmetic mean, we'll just call it the mean, and in the future we're only going to be dealing with the arithmetic mean. There are other kind of means, but if I ever use one of those, I'll let you know. Until then, we're just sticking with this kind of mean. So the arithmetic mean is a single value meant to sum up a data set. Like let's say you have this data set, 1, 1, 2, 2, 2, 3, 3, 4, 5, 5. What single value could best represent this data? So to calculate the mean, first you add up all the values and then you divide by the total number of values that you have. So we add together those 10 numbers, then divide by 10 because we have 10 numbers. So for this data set, we find a mean of 2.8. So for that data set, we found the mean to be 2.8. So for this data set, what would you expect the mean to be? Now we could probably expect it to be higher because the numbers that are going into it are much higher. So we would expect the average value, the representative value for this data set to be higher than the other one. So we add everything together, divide by 10, and find a mean of 41.3. So we find a larger mean of 41.3, which makes sense because the numbers in this new data set are much larger than those in the original set. So there are actually two types of arithmetic mean. We have the population mean and the sample mean. They're calculated exactly the same way, but there are important differences in how they are written. So we have the population mean, which is the Greek letter mu, which is a little u-looking thing. And sample mean, you might see it written one of several different ways. We have X bar, or maybe capital N. It depends who your teacher is, what book you're using, but they both mean the same thing most of the time. So pay attention to this now because in the future it'll be important and you might end up making a minor mistake just because of this one little thing. So the formulas are both doing the same thing, but they use different annotations. Notice that you're adding together all the x's. That little e looking thing next to the x, that means the sum of. It's called sigma, the sum of all x divided by the number of x's you have. Notice that the capital N represents the size of a population, and the lowercase n represents the size of a sample. So back to the original example, remember we found the mean of 2.8, first by adding up all the values on top, and then dividing by the total number of values that we had. And that's all there is to it. That's the arithmetic mean, and realize the subtle differences between the population mean and the sample mean.